Okay guys, today we're going to be talking about solving different kinds of equations. So how do you solve and check an equation? We're going to be doing both. And some of the properties we'll go over you'll have already seen as well. So some of it is not all new. First example, in the board game Monopoly, Boardwalk is the most expensive property. The one-time cost of a property plus a hotel is $1,400. It's pretty important. While the rent earned from another player landing on it is $2,000. If n is the number of people landing on the boardwalk property, then P of n equals 2,000n minus 1,400 is the owner's total profit after n players land on the property. So let's talk about this for a little bit. So if you play Monopoly and you land on, say, some kind of property that you want to own, you have to pay a certain amount. So it looks like the property plus a hotel, to put a hotel out there, saying that you own it and then somebody else has to pay you if they land on it. In this case, it's $1,400. So you have to pay that amount. That's where this kind of comes from. You're paying the $1,400, right? We're trying to figure out the profit. So they're subtracting the $1,400, but every time somebody lands there, you get 2,000. So it just depends on the number of people landing on there. So n is the number of people landing on it. And so if you do this calculation, you find the profit, P of n, right? Because you figure out how much money you made minus how much you had to spend on it, and that's your profit. All right, so part A, what will the owner's profit be after 4 people land the boardwalk? So where do we put 4, the number 4? That goes in for n. If you look up here, it's the number of people landing on the boardwalk. So 4 goes in for n, and we'll put that in both places. So it'll look like this, P of 4. We're going to find the profit when there's 4 people landing on it is 2,000 times 4 minus 1,400. Remember, the left-hand side stays the same, P of 4. Calculate this. This would be 8,000 minus 1,400. So what's our final answer here? P of 4 equals what? Looks like it's going to be 6,600. That would be your profit if 4 people landed on the boardwalk that you own. Okay, part B. Is it possible for the owner to make exactly $10,000 in profit? And that's what we're going to check in the calculator. Hopefully we can bring that up and see. So the question is, if we know the profit is $10,000 and we look at the profit on this side of the equation, that's where the profit is. They're asking, can this side, the left-hand side, ever be equal to $10,000? Can you ever have P of n equal to $10,000? So we're asking this question. Can you have 10,000 on the left-hand side and figure out how many people you'd have to make it $10,000? So basically, one way we could do this is we can solve this equation for n. And that will be like the first way we do it. And then we'll get to the calculator part in part C. So how do we solve this for n? Well, we got to move over the 1,400, and then we're going to get rid of the 2,000. So we add 1,400 first to both sides. It's a plus sign, 1,400. So that means this is 11,400. The other side is 2,000n. And then what do we do after this? To get rid of the 2,000, we would have to divide. So we're going to do 11,400. Let's just rewrite it. Equals 2,000n. And we divide both sides by 2,000. We cross out. So what would this be? Does it come out to be a nice whole number? Because that's what we're really looking for. So we take 11,400 and you divide it by 2,000. What do we get? Looks like it's about 5.7. So is it possible to make exactly $10,000 in profit? No, because we don't have a nice whole number for the number of people that has to land on it. So is it possible? No. We'd have to have at least, this is between 5 and 6 people landing on it. 5, you wouldn't have enough money, profit. 6, you would have enough, but it would be over 10,000. So we're going to check our answers to part A and B by pulling up a table in your calculator. So again, we would do this in class with a graphing calculator, but we don't have one. So we're going to have to go to Desmos calculator again. So this is desmos.com/calculator. So we're going to have to put in the equation. To put in the equation here, we're going to have to change the p of n because it doesn't like that. We're going to use y, and we'll just use x. So our equation we're going to be putting in there is y equals 2,000 n, or no, x. We have to change it already. 2,000x minus 1,400. The graph's not going to look too great because 2,000 is a lot. So let's try it. Y equals 2,000 x minus 1,400. So you just see like a straight line. That's because we're so far in. You're not going to see much unless you really zoom out. I don't even know how far you'd have to go out to see it, but it's pretty big. So we're not going to really worry about the graph part of it, but we just want to bring up a table. So hit the gears, and it says convert to table. We'll do that. And we're going to go down here and click, and we're going to get some more values. So hit enter a couple times. Okay, we'll go up to about 9. So let's see. If there are 4 people who land there, we got it to be 6,600. Is that true? If we look at 4, there it is, 6,600. This is telling us the profit on this side, and this side is telling us how many people are landing there. And then we were trying to look at, see if we get 10,000 exactly. Well, that should land somewhere in between 5 and 6 people. So 5, it's 8,600. 6 is 10,600. And so if we look at that, that one's the closest to 10,000. So it is close to 6, but not quite. That's where we get the 5.7. So it does it agrees with what we found. Now this is finding it algebraically here, and then doing it this way is finding it with the table. So it should all hopefully make sense no matter which way you do it. All right, let's solve some equations now. Distributive property, something new. Hopefully everybody knows what that is. So for all real numbers, a, b, and c, if you have a c sitting on the outside of parentheses with a plus b on the inside, then if you distribute that, like we usually draw this, so arcs go to both of them. So the property is c times a, multiply it to that, and then we do c times b and add them together. Again, the whole reason of distributive property is because you normally can't put these two inside parentheses together. They may not be like terms. So this is kind of the outside the scope of PEMDAS, whereas normally people want to do distributive property all the time when they see parentheses, but when you see PEMDAS with just numbers, you don't have to. So we go down the example below, example 2, solve 5 plus 3 times c minus n equals 12.5. Well, can we put these together? No. Thus we need distributive property. So we multiply it out, 3 times c and 3 times negative 9. So let's solve this one. We have 5 plus 3c minus 27 equals 12.5. All right, now how do we solve this? Well, we can combine like terms now on this side. We have 5 and we have negative 27. So let's put them together. We have 3c minus 22 equals 12.5. Okay, after that, we add 22 to both sides. So we get 3c, those cancel, equals 34.5. And then we divide. This will also give us a decimal. C equals what? So we just divide them. What do we get? Should be 11.5. There we go, we solved one. Hopefully that was easy, not too difficult for you to distribute. We did this a little bit like on the first or second day of school. And it's okay to get decimals. What we don't really like is fractions. So we're going to learn how to clear the fractions so we don't have to deal with fractions in our equations, because this looks pretty nasty down here. So how do we do that? To clear a fraction, you have to find the least common multiple between all the denominators. You should know that denominator means it's the bottom part of the fraction. So how do we do that? Here, if we have 3 and 4, what's the least common multiple? That means if you were to take 3 and 4 and you were to write the multiples, that means you just keep adding the same number, like 3, 6, 9, 12, 15, keep going, right? If you look at both of these sets, do the same thing with 4, keep adding 4, 8, 12, 16, 20, keep going. As soon as they first match the same number in common, that would be called their least common multiple. So that would be what number? What do they have in common as their least common multiple? The first time it happens is the number 12 on both sides. So that's the number we're going to use to multiply the entire equation by to get rid of fractions. So I'm going to put a huge set of parentheses around the entire equation. Really what we're doing is we're multiplying both sides by 12. You're allowed to do that as long as you do it to both sides. But I'm going to basically do a big distributive property where 12 is being multiplied to everything over here. It's also going to go to these things as well. So let's do that. 12 times 2/3. Well, hopefully you can do that in a calculator. If not, you end up getting, you multiply it across the top, you get 24 divided by 3. Right, so that should be 8x. Do the same thing here. We get 12 over 4. So that's plus 3x equals 12 times x is 12x. And you multiply them together. So it's 12 times 3.75 should be 45. So no decimals anymore, actually. All right, we can combine like terms on the left-hand side and put them together to get 11x equals 12x minus 45. Let's go ahead and move the 12x to the other side by subtracting 12x. That would give us a negative 1x equals negative 45. And just divide by our negative 1. So x equals 45. The nice thing about doing this is once you find that common multiple and multiply it through everything, we no longer have any fractions. And that's kind of the whole goal of doing that. Let's try another one like that. But now it's going to be a word problem. So we only have 2 more examples left. So example 4. In Game 5 of the 2000 NBA Finals between Miami and Dallas, Dirk Nowitzki scored 1/5 of Dallas's points. And we have Josh Howard, who scored 1/4 of Dallas's points. The rest of the team scored a total of 55 points combined. How many points did Dallas score? So we're trying to figure out how many points they scored total. And as a hint, it's pretty good to identify some kind of variable for points. In this case, we're going to say P is the total number of points that Dallas scored. So let's try to figure out how we can create this formula, this equation. So we have 2 people. We have Josh and Dirk. Josh and Dirk. So let's talk about Josh. Josh, he has 1/5 of the points. So this is how I'm going to write that out. It's 1/5 times the number of points. And the total number of points that they got, we don't know. So we're going to do 1/5 times P. That's Josh. He had 1/5 of the total points. Plus, go through here again. Oh, wait, I got it backwards. The first one's Dirk. Dirk did 1/5, right? Dirk Nowitzki scored 1/5 of Dallas' points. Josh scored 1/4. So we're going to do Josh. He scored 1/4 of the total points. Again, times P. The rest of the team scored a total of 55 points. So together, everybody else who was playing, they scored a combined points total of 55. So we're going to add 55. So the fraction amount that Dirk had and the fraction amount that Josh had plus the 55 should equal the total number of points that Dallas scored. And what letter is that up here? It's just P. So equals P. So all these together combined should give the total number of points that Dallas scored. So how do we get rid of the fractions? Because we don't like them. Least common multiple. So off to the side, we have 5, 10, 15, 20, 25. You can keep going. We have 4, 8, 12, 16, 20. There it is. 20 and 20. That's the least common multiple. So we multiply both sides, the entirety, by 20. So distribute that to absolutely everything there. So what do we get here? We get 4p plus 20 times 1/4. That would be 5p. Plus 20 times 55. A lot of students forget to do it, multiply this part here, the 20 times 55. That's absolutely important. Otherwise, you'll get a way off answer. That's 1100. Equals, don't forget to do this one as well, 20 times p, or 20p. Okay, now it's a lot easier. Combine like terms, you get 9p plus 1100 equals 20p. Subtract 9p. So we have 1100 equals, oh, look at that, 11p. Divide both sides by 11. What do we get? Maybe you can see what it is just by looking at it. It's going to be 100 points total. So how many points did Dallas score? Total, Dallas scored 100 points because the P was the total number of points that Dallas scored. And that's what we found here. We could also find out how many points did Dirk score by looking at this. So we do 1/5 times that. Maybe you could figure out what that was. And 1/4 times the total number of points would be with Josh. So Dirk would have scored how many points? 20. And Josh would have scored 25. If you would multiply that by 100. So a lot of students get tripped up on this one, but just you got to take your time. And a lot of times when you set this up, the other side of the equation just ends up being just the variable by itself. That happens pretty often when you're trying to find the total number of points and you identify the variable as the total number of points. That's usually what happens. All right, last example. Opposite of sum theorem, which is the exact same thing pretty much as distributive property. For all real numbers, a and b, if you have a negative number outside, a lot of students like to do -1 and then just say, oh, I'm distributing -1. That's fine. So what does that look like? Well, you would have -a plus a -b. More importantly, what I don't like to necessarily see, even though a lot of students do this still, is I'm going to change this to having a plus minus. That means the same thing as -a, just minus b. I don't usually write the plus minus, this stuff. When I see that, I change to this. A lot of students like to do that. Is flip it, go the other way. But I prefer not. Our last one. Suppose g of a equals 3a minus the quantity 7 minus 5a. For what value of a is g of a equal 12? This is a hard one to set up because your students don't really know what to do with this g of a or what that means when it says equals 12. A lot of people like to put in 12 for a, but we don't know what a is. It says for what value of a. We're trying to find a. So a is going to stay in the problem. What we are replacing is the entirety of g of a is now 12. So 12 is going to go in for the entire left-hand side, g of a. So it's going to look like this, 12 equals 3a minus the quantity 7 minus 5a. Now we have an equation where we can solve for a. So we're going to work on the right-hand side by distributing the negative. So you have a negative times a positive here, so that's -7, -7, and a negative times a negative is a plus 5a. Hopefully you can finish this off from here. 3a and 5a together would make 8a minus 7. And then we're going to add 7 to both sides. That's going to be a really ugly answer. So we get 19 equals 8a divided by 8. So we get what? A equals a little over 2. 2.375. And that would be your final answer. In this particular case, we did not have any fractions, so we didn't have to find a least common multiple. We're just practicing using distributive property when there's a negative sign on the outside. You could have also put a -1. If that's easier for you, that's fine as well. So I think you have everything you need to answer the rest of the huddle and the mastery. If you have any problems with any of that, I would suggest going back and looking at ones that we did that were very similar. I think everything should be okay with those. Maybe one thing I want to say is about this one here. When you do the least common multiple and you're going by, well, we might as well just do that. sometimes students say that you can just take these two numbers and multiply them together, and that could be your least common multiple, which does work. However, sometimes it's not the least common multiple. It's just a common multiple. If you multiply them together, you get 60. You could multiply the entire thing by 60. That would be fine. Just you're dealing with bigger numbers. That's all. If I write out the least common multiples here, you notice that the first one that actually comes up is not 60, but it's 30. They have that in common. So I would suggest multiply by everything by 30. So I'll start this one with you because students don't really know what to do with this division by 6. But just remember, it's over 1. So what you're really doing is you're doing 30 divided by 6. So 30 divided by 6 is what? So that's 5. And then you have it attached to h. Plus 30 divided by 10 is 2h. Don't forget 30 times 1 is 30. And you should be able to hopefully do it from there. I think that's everything I'm going to go over with you, and you should be able to finish the rest and be able to do the homework there. Okay, so that was all for 1.5. 1.6, right? 1.6, yes.